Today the topic of discussion is closure of an attribute. It's very important topic before studying candidate key. How to calculate candidate key? In order to calculate candidate key from a table, you have to understand what is closure of an attribute, because it's a prerequisite of calculating candidate key. So let's start with the closure. So what is the definition of closure? Is that closure of an attribute, set of all attribute which can be computed from given attribute. That is, what are attribute which can be computed from a given attribute. Suppose I have given an attribute A or a column A, then what are different attributes which I can derive from A is called closure. Suppose with the help of A I can determine A, B, C, D, then this A, B, C, D is closure of A. Fine. Okay, so let's understand the question. The question is given a relational schema PQRSTU. Yes, there are 1 2 3 4 5 6 columns. The names of columns are PQRSTU and the table name is R. Using following functional dependency, this is functional dependency given to you. Determine closure of PQ. You have to determine what are the closure of PQ. So how to determine closure of PQ? You write PQ, fine, and you write plus, okay, on superscript or subscript, whatever you want to write you can. So PQ closure is what? In PQ closure, PQ will come. In any of the closure, that same attribute will come. So first of all, PQ will have PQ, and now from the functional dependency, see what PQ can do. PQ is determining R. In right side there is a PQ, then you can also put R over there. Fine. So because PQ can determine R, so R can come. So this is over. Now take this. QR can determine PS. So is there QR here? Yes, we have QR over here. So with the help of QR completely you can determine PS. Since P is already there, so you no need to repeat, no need to write PS like this, because P is already there. So you can write only S. Fine. Okay. So I can write S. Fine. So I've used this functional dependence. Now S can determine T. So do I have S? Yes, I have S. So with the help of I can determine T. So I've written T. R, U. With the help of R and U, I have only R. I don't have U. I have only R. I don't have U. So with the complete R, you can determine Q. But since you have only R, so you cannot determine Q. Although Q is already there, but with you need all this complete information. So this is the closure of PQ, that is PQ, RS and T. Fine. So let's solve this question. So you have given a question. The question is given a relational schema R, PQ, RS, T, U, using the following functional dependency. This is the functional dependency given to you. Determine the closure of QR and PR. Okay, so let's start. QR, the closure of QR. QR will have what? QR, I just told you. The closure will always have the attribute, same attribute QR. Now use functional dependency. With the help of P, you can determine Q. Is there any P? No. Now use this. QR, with the help of QR, you can determine ST. So I can write ST over here. Fine. So I've used this. With the help of PTV, you need all three attributes. PTV, I have T, I don't have P and I don't have V, so I cannot determine V. So only what I can do is that with the help of what QR can determine, only QRST. Fine. Again I use PR. So now I am finding closure of PR. So PR will have PR. Fine. Okay. Is there P? Yes, P. Now P can determine Q, so Q will come. Fine. QR. Is there QR? Yes, there is QR. QR or RQ, both are same. Yes, with QR you can determine ST. S and T. Write S and T over here. With PTV you have P. Yes, you have P. You have T. Yes, I have P also. I have T also. Do you have V? No, I don't have V. So if you don't have V, you cannot use this functional dependency. So the closure of PR is only PR QST. Fine. So what is the answer? QRST, QRST. Fine. And PRQST. So this is the answer. Answer. So let's check. Yes, definitely. This is the answer. QRST and PRQST. Fine. Let's solve another question. So given a relational schema, there are 5 attributes PQRST. Using functional dependency, this determine closure of Q and T. So let's find the closure of Q. Q closure can have Q, because I just told you a closure can have same attribute. Now start with this function. P. Is P over here? No. So I cannot determine QR. Is Q over? Yes, Q is there. I can determine S. So I'm writing S over. Is RS over here? Only S I have. No RS. So I cannot determine T. Is T over here? No, I don't have T. So I cannot determine P. Again move. Is P over here? No. Is Q? Yes, Q is there, and I've already determined S. So with the help of Q, you can only determine two attribute Q and S. Now take closure of T, as your question is to find closure of Q and closure of T. So closure of T will have T. Fine. So let's start with the functional dependency. Let's start. Is P over here? No, there is only T. Is Q over here? No, there is only T. Is RS over here? No, we have only T. Is T over? Yes, I have T. So what you can do? You can use TP. Fine. So now your work is not over. You move to this functional dependency till you are getting the same answer. Now you come again with check the first. Is P over here? Yes, now you have P. So what you can do? You can find QR. So you can find QR. Fine. Is Q over here? Yes, you have Q now. You can find S. So fine. Is RS over here? Yes, you have RS. With the help of RS, you can determine T. As T is already there, so no need to write T again. So what is it will remain same. Is T over here? Yes, you can determine P. And since P is already, I'll not do anything. You move again. Is P over here? Yes, you can determine QR. QR is already here. So on moving n number of time, you will get the same answer. So you stop here. And finally, the closure of T is what? TPQRS. So the closure of T is TPQRS and closure of Q is QS. So finally, the answer is what? This A. Let's check. Yes, the answer is A. Finally, you're getting the concept of closure of an attribute. So after this, we'll start with candidate key. Till then, thank you so much.